All right, brothers, my fellow colleagues, this is 387, first unique character in a string. Given a string, find the first non-repeating character in it and return its index. If it doesn't exist, return -1. This question, first unique character, basically is kind of the reverse of if a string contains a duplicate, right? So you're employing the same ideas here. It's just the way you derive the answer is going to be different. So a cool way to think about this is just to, whenever you have to do something similar like this, where you have to derive a question based off number of occurrences of something in a list, or if something's the first of something, an easy way to do that is a hash map or a dictionary. So the basic idea here, so we can kind of think of the scaffolding here, create a dictionary, right? For each letter in the dictionary, we're going to, so imagine the string is Leet. We're going to create a dictionary where for a mapping of letters to occurrences. Boom. So if we go through this string, we'll be like, oh, we'll count if L, we'll see L is here, right? There's nothing in the list when we start, right? So what we'll do is we'll add L, and we'll say there's one occurrence of L. Then we go through the list. The second letter. There's only one occurrence of E. Go to the next index. We found another E. We'll increment that. Go to the next index. We found a T. Increment that. So the answer to this for this string, for this function, the first unique character in this string Leet would be L, right? So you can see that once we build the dictionary, we just have to iterate through the dictionary or the string, and then we can just return the index of the first letter that only has occurrence 1. So we can do that, right? So create a dictionary. We'll just call it ldict is equal to just a basic literal dictionary. Then we're going to do for letter in S, and we're going to say if letter in ldict, then ldict sub letter is equal to ldict sub letter plus 1. So we're going to increment the value, right? If E is already in the dictionary, we're going to add 1 to the value of whatever E is already. So 1 goes to 2, 2 goes to 3, and so on and so forth. Else, if it's not in the dictionary, then we're just going to initialize it, right? If it's not in the dictionary, then we're going to put it in the dictionary and set it to 1. So we have the dictionary created here. So then, the second thing we're going to do, we have to return the index of the first unique character, right? So we can just iterate through the string, which is say for index in range of the length of S, and then we're going to say if S sub index in ldict, if S sub index, my bad. So we're going to look up the letter. So S sub index is going to give us the letter for this index and then we're going to check if it's equal to 1, right? This would be the linearly iterating through the string and trying to find which key in the dictionary has occurrence 1, right? So if it's equal to 1, then we'll return the index, right? Otherwise, I mean, if we got through here and we didn't return at all, then we'll just assume that it doesn't exist and we'll just return -1. So we should be able to run this and it should be fine. Invalid syntax. Oops. So yeah, there we go, 148. It's not too bad. I just did this and it got like 128, so times varies here. First time doing this problem, by the way. So time complexity, right? So we have to linearly iterate through the string the first time to create the dictionary, right? And then we have to linearly iterate through the string again to find which index has the value 1. So it's going to take linear time. I mean, which letter has the occurrence equal to 1. So it's going to take linear time. The space complexity here, since we're creating a dictionary, right, and there can only be unique values, and the question says you may assume that the string only contains lowercase English letters, right? So it doesn't matter if the string is equal to, it doesn't matter if the string has like 3, whatever characters, 3 trillion characters in it or whatever, right? Our dictionary can only store unique values. So in our dictionary, there will ever only be 26 possible keys, right? Right? Because the alphabet has 26 letters. And since we can assume they're all lowercase, this kind of works to our favor. So the space complexity here is actually going to be constant time because no matter how large the string we pass in here, we're going to use 26 keys that map to occurrences to find out which letter has occurrence of 1. So we have linear time, constant space here, and that is 387, brothers.